Welcome to episode 65 of your CYSA Plus Prepcast. In this session, we will explore industry frameworks for vulnerability management, structured methodologies that guide how analysts identify, evaluate, prioritize, and remediate vulnerabilities across modern digital environments. These frameworks offer standardized approaches that align with regulatory requirements, best practices, and real-world threat landscapes. Whether defining scan schedules, selecting configuration baselines, or prioritizing critical findings, frameworks provide analysts with the necessary structure to manage vulnerabilities consistently and defensively. Understanding these frameworks not only helps you become a more effective cybersecurity analyst, but also prepares you to meet key requirements on the CYSA Plus exam. Let us begin by defining what vulnerability management frameworks are. These frameworks are published standards, guidelines, or methodologies developed by recognized cybersecurity organizations. They help define how vulnerability management processes should be structured and executed. These frameworks support consistency, alignment with regulatory expectations, and improved risk reduction outcomes. Rather than inventing custom approaches for each organization, analysts use these frameworks to build repeatable, scalable programs that align with industry-accepted norms. One of the most important frameworks is the Common Vulnerability Scoring System. CVSS allows analysts to assess and quantify the severity of a vulnerability using a set of standardized metrics. These metrics include exploitability characteristics such as attack vector and attack complexity, as well as impact categories such as confidentiality, integrity, and availability. Each vulnerability is assigned a numerical score, typically between 0 and 10, which helps teams prioritize remediation based on potential risk. This structured scoring approach helps analysts avoid subjective decision-making and allows organizations to allocate resources toward the most serious threats. CVSS scoring is a cornerstone of vulnerability prioritization strategies. High-scoring vulnerabilities, especially those with active exploit code in circulation, are prioritized for immediate remediation. Medium or low-severity vulnerabilities may be addressed during routine patch cycles or tracked for changes in exploitability. CVSS enables vulnerability management teams to adopt a risk-based approach to patching and to communicate severity clearly to business stakeholders. It also supports compliance by demonstrating that vulnerabilities are assessed using an industry-recognized scoring methodology. Another important framework is the National Institute of Standards and Technology Cybersecurity Framework, also known as the NIST-CSF. This framework is widely used across industries to manage cybersecurity risk, including the identification and mitigation of vulnerabilities. The NIST-CSF is structured around 5 core functions: identify, protect, detect, respond, and recover. These functions guide organizations in building comprehensive security programs that incorporate vulnerability management as a foundational component. NIST-CSF is particularly useful for aligning technical activities with business risk objectives and strategic planning. Cybersecurity analysts use the NIST framework to design vulnerability management processes that align with organizational goals. Under the Identify function, asset inventories and vulnerability scans establish visibility. The Protect function includes applying patches and configuration baselines. The Detect function focuses on identifying configuration drift and vulnerability exposure. Respond and Recover cover incident response and remediation processes. This structured lifecycle ensures that vulnerabilities are not only identified, but also tracked, addressed, and reviewed as part of a larger risk management context. The Center for Internet Security Benchmarks represent another crucial framework in vulnerability management. These benchmarks are consensus-based configuration standards developed by cybersecurity professionals across industries. They provide detailed guidelines on how to securely configure operating systems, network devices, databases, and cloud platforms. Analysts use these benchmarks as the foundation for secure configuration baselines. By scanning for deviations from CIS benchmarks, analysts can identify misconfigurations that represent vulnerabilities and prioritize remediation based on policy violations. CIS benchmarks are widely supported by major configuration assessment tools. Analysts perform baseline scans using scanners like Qualys, Nessus, or Microsoft tools that compare actual system settings against the CIS recommendations. Each non-compliant configuration is flagged as a potential vulnerability. This form of scanning supports both security hardening and compliance efforts. By adopting CIS benchmarks, organizations benefit from standardized configuration requirements that reflect current threats and operational realities. Another essential framework is the Payment Card Industry Data Security Standard. PCI DSS defines specific vulnerability scanning requirements for organizations that process, transmit, or store credit card information. These requirements include performing both internal and external scans on a regular basis, remediating critical vulnerabilities within specific timeframes, and documenting the scanning process for auditors. PCI DSS ensures that organizations within the payment processing ecosystem maintain a consistent and auditable approach to vulnerability management. For analysts managing PCI compliance, vulnerability scans must be performed by approved scanning vendors and follow strict scheduling and documentation requirements. Any critical or high-severity vulnerabilities discovered must be remediated and rescanned to confirm resolution before compliance can be confirmed. PCI DSS not only enforces vulnerability management practices, but also integrates them into broader data protection requirements such as secure network architecture and access control. The Open Web Application Security Project Framework focuses specifically on application layer vulnerabilities. OWASP publishes extensive guidelines on secure coding and application testing, including its widely known Top 10 list of the most common and dangerous web application vulnerabilities. Analysts use the OWASP Top 10 to guide vulnerability assessments, penetration testing, and secure software development efforts. Common issues addressed include injection flaws, broken authentication, sensitive data exposure, and security misconfiguration. This blockchain suppresses offenses. For more cyber-related content and books, please check out cyberauthor.me. Also, there are more security courses on cybersecurity and more at baremetalcyber.com. Now let us turn to practical implementation and best practices for applying industry frameworks in vulnerability management. Most organizations do not rely on a single framework. Instead, analysts combine several to form a unified strategy that meets operational, compliance, and security needs. For example, they may use the NIST Cybersecurity Framework for Strategic Alignment, CVSS for Severity Scoring, CIS Benchmarks for Secure Configuration, and OWASP for Application Layer Security. This integration ensures that vulnerability management is both comprehensive and adaptable to multiple layers of the environment. Effective implementation of these frameworks begins with clear mapping. Analysts document how each phase of the vulnerability management lifecycle aligns with specific framework elements. This includes detailing how vulnerabilities are discovered, assessed, prioritized, remediated, and tracked. Mapping also includes cross-referencing controls across multiple frameworks where overlap occurs. For example, a system hardening standard may align with both CIS controls and PCI DSS requirements. By making these connections explicit, analysts can avoid duplication and ensure compliance across regulatory and internal policies. Integrating vulnerability findings with threat intelligence data is a best practice that enhances the value of framework-based assessments. Analysts enrich vulnerability scan results with context about active exploitation, malware campaigns, and attack trends. For instance, if a vulnerability has a high CVSS score but is not being actively targeted, it may be treated with less urgency than a lower-scoring vulnerability currently exploited in the wild. Threat intelligence integration allows teams to respond to real-world risk rather than theoretical severity alone, helping prioritize limited remediation resources. Vulnerability management frameworks also support improved asset and risk visibility. Analysts use these frameworks to define asset criticality, identify ownership, and determine exposure levels. This information helps analysts assign risk levels to each vulnerability based on where it resides and what it could impact. For example, a vulnerability on a public-facing server with access to sensitive data may be prioritized over one on a test system. Frameworks ensure that this prioritization is done consistently and in alignment with organizational goals and security policies. Another important best practice is integrating vulnerability data into central management systems. Analysts feed scan results into platforms like security information and event management systems, governance risk and compliance tools, and enterprise risk dashboards. These integrations allow vulnerability data to be correlated with other indicators, mapped to business risk, and reported in real time. This enhances decision-making, supports automated workflows, and gives stakeholders a clear view of the organization's risk posture. Robust documentation practices are essential to effective framework implementation. Analysts document how frameworks are applied, what scanning tools and methods are used, how remediation is prioritized, and what compliance evidence is collected. Documentation ensures transparency and repeatability and provides a clear audit trail for both internal reviews and external audits. When compliance with regulations like PCI DSS, HIPAA, or GDPR is at stake, well-maintained documentation is often the difference between a successful audit and a failed one. Collaboration across teams is another critical success factor. Vulnerability management is not performed in isolation. Analysts must coordinate with system administrators, developers, compliance officers, and business stakeholders. They communicate framework requirements, scan schedules, and remediation priorities clearly and consistently. Collaborative planning ensures that remediation activities are properly resourced, system owners understand expectations, and operations continue with minimal disruption. To maintain effectiveness, analysts must stay current with the frameworks themselves. Cybersecurity standards evolve in response to new threats, technologies, and compliance requirements. Continuous training ensures that analysts understand the latest scoring methodologies, secure configuration baselines, and threat actor tactics. This includes learning how CVSS scoring evolves over time, how NIST publishes updates to its cybersecurity framework, and how OWASP refreshes its top 10 vulnerabilities list. Staying informed ensures that analysts apply frameworks effectively and continue to protect systems using current best practices. Frameworks also evolve beyond compliance tools. When applied strategically, they serve as roadmaps for security program improvement. Analysts use framework assessments to identify systemic weaknesses, track progress over time, and guide investments in technology and processes. For example, repeated findings of weak configuration management may indicate a need for better asset control or automated deployment tools. By aligning findings to frameworks, organizations can mature their security capabilities and make data-driven decisions that reduce long-term risk. To summarize episode 65, understanding and applying industry frameworks for vulnerability management allows cybersecurity analysts to implement consistent, structured, and effective security practices. Frameworks such as CVSS, the NIST Cybersecurity Framework, CIS Benchmarks, PCI DSS, and OWASP Guidelines each serve unique but complementary roles in helping organizations reduce risk. By integrating these frameworks into scanning, assessment, remediation, and reporting workflows, analysts create mature, auditable, and resilient vulnerability management programs. These capabilities are essential for success on the CYSA Plus exam and are foundational to real-world cybersecurity effectiveness. Stay tuned as we continue your comprehensive journey towards CYSA Plus certification success. Thanks for listening. To learn more about cybersecurity, please visit baremetalcyber.com. There you will find best-selling books, videos, and even more free cybersecurity training courses. Please subscribe to the Prepcast and our various podcasts. And thanks for listening.